Okay, welcome once again to the easy world of science. Today we will take a look at glycolysis. We will discuss the glycolytic pathway, the definitions, the stages involved, the biochemistry of the reactions, then the enzymes involved, the implications of the enzymes, the inhibitors, the energetics of the glycolysis, and equally the problems associated with the deficiencies of the glycolytic enzymes. So, our topic today is glycolysis. So, first, by definition, glycolysis is the conversion of glucose to pyruvic acid. And you can also see this pyruvic acid as pyruvate. So the conversion of glucose to pyruvic acid is called glycolysis, and it occurs in the cytoplasm of a cell. Glycolysis takes place in the cytoplasm of a cell. And glycolysis is an important stage in internal respiration, that is in cellular respiration. Whether it's going to be aerobic or anaerobic, glycolysis is important. Glycolysis is the only pathway by which glucose is degraded to yield energy. Remember, there are other uses of glucose in our body apart from providing energy, but glycolysis ensures that glucose is used to give us energy. Now, you should note this, that it occurs in the cytoplasm. So the enzymes that controls glycolysis are found in the cytoplasm of a cell. And the end product of glycolysis is pyruvic acid, otherwise known as pyruvate. The introduction to this is that glycolysis is a 10-step reaction. It's a 10-step reaction where some authority divides the 10 into two. You have the two out of the 10, you divide it into two stages, stage 1 and stage 2. In stage 1, some authorities may divide into 4 stages, but people that divide into 2 stages, that is the first 5 stages, or the first 5 steps. First 5 steps. Then here is the last 5 steps. This first 5 steps is actually known as the investment stage or the preparatory stage. The investment stage or the preparatory stage or the energy consuming stage. It is energy consuming. While here is the payoff stage or the energy yielding stage. So these are the first 5 steps is the investment stage, it consumes energy, whereas the last 5 steps out of the 10 steps is the energy yielding or the payoff stage in the glycolysis. Now, what matters is that it is a 10-step reaction. Then some authority may divide it into 4 stages, stage 1, stage 2, stage 3, and stage 4. All these will still be a 10-step reaction where they assume that the first step is still the energy yielding stage. Energy yielding stage or the preparatory stage is similar to this. Then the stage 2 is neither energy yielding nor consuming. Neither energy yielding or energy consuming stage. Then the stage 3 is actually the energy yielding stage, neither energy yielding nor consuming. Then the stage 3 is actually energy yielding stage with the conversion of the glyceraldehyde to an acid. Then the stage 4 is also energy yielding. But what matters is just to recover the recovery of phosphate groups. It is also energy yielding. This is the phosphorylation stage. Phosphorylation stage. Then here is neither energy yielding or consuming. Then here energy is yielded. Then there is a conversion of a kind of aldose to acid at this stage. Then here the phosphate group added in the first stage is recovered in the last stage. whether you are using the 2 stages or the 4 stages, what matters is that glycolysis is a 10-step reaction. So it depends on what authority you are using, but the 10th step is what I will teach you. For you to understand these 4 steps, stage 1, we say energy, not energy yielding, please. Stage 1 is energy consuming. Not yielding, please. Energy consuming, that's energy consuming stage. And is a phosphorylation level. Then here, neither yield or consume any energy, which means ATP is used up here. Then here, energy is produced, and there is a conversion of glyceraldehyde to an acid. Here, there is the recovery of the phosphate group that was added to the glucose in the stage 1, in the last stage. Or some authority can simply divide it into 2 stages. Energy yielding stage, which is the last stage, and the energy consuming, which is the first 5 stages. Glycolysis is a kind of business whereby you invest an ATP and get more of the ATP. So for glycolysis, at the first stage, 2 molecules of ATP are invested, which means you use up 2 molecules of ATP. Then at the stage 2, that's the last 5 steps, 4 molecules are provided. So when you say 4 minus 2, the net yield of energy from 1 molecule of glucose is 2 molecules of ATP. The first step uses 2 molecules of ATP, then the second step produces 4 molecules of adenosine triphosphate, and in that case it shows that the net yield of energy is actually 4 minus 2, because it's like in a business where you invested 2 molecules of ATP and your final gain is the final money you realize after the sale should be 4 ATP. Then when you minus the cost of production, that's the one invested, what remains for you is your gain. So 1 molecule of glucose gives us a net yield of 2 molecules of ATP during glycolysis. That is in the anaerobic phase. But in aerobic phase, 1 molecule of glucose yields 8 molecules of ATP. I will explain when we come to the energetics of glycolysis. Remember, you have to follow these glycolytic reactions step by step in this channel. I'm going to detail everything, but I won't rush it. Remember, you need to use your comment box to ask your question. And this channel requires a sponsor. The little you can do to spread the light, to help me in this good job I am doing, please do as little as you can, and God should bless you. Now, let us see this 10-step reaction. I will give you the summary of the 10 steps, then come to details of each step and the enzymes involved, telling you the details. So the summary of the glycolytic pathway. So let's see the pathway, glycolytic pathway. First, this pathway was discovered by 3 scientists. Gustav Embden, that's Gustav Embden, then Otto Meyerhoff, and Jakub Karupanas. So in view of this, these first 2 people, their first name is also the name for this pathway. So glycolytic pathway is also called Embden-Meyerhoff pathway. Embden-Meyerhoff pathway. So the discovery which determines the name. And remember, I told us it takes place in the cytoplasm. Okay. We will take it in a summarized way, the much we can. First, we have the glucose. The first step is that the glucose is converted to glucose is converted to glucose 6-phosphate by the enzyme hexokinase, or what we call in the liver, the correct hexokinase there is glucokinase. In this case, there is hydrolysis of 1 molecule of ATP to ADP. That means you add a phosphate group to glucose. That's, you remove the source of phosphate group here is the ATP. And what is present here is magnesium ion. Then from glucose 6-phosphate, this reaction is actually irreversible. Glucose 6-phosphate is now isomerized to fructose 6-phosphate. The enzyme involved here is actually specifically is an isomerase, but the correct isomerase is phosphohexose isomerase. That's the enzyme. Then the third step is another phosphorylation reaction, whereby fructose 6-phosphate is phosphorylated to fructose 1,6-phosphate or fructose 1,6-biphosphate. Which one? Or you say diphosphate. The enzyme involved here is phosphofructokinase 1. That's PFK1. Then the next thing here is the fructose 1-bisphosphate is now split into two triose compounds. That is, we have glyceraldehyde 3-phosphate and dihydroxyl acetone phosphate. Dihydroxyl acetone phosphate. Then the next is the enzyme involved in this splitting is called aldolase. Aldolase is the enzyme involved in the splitting of this fructose 1,6-bisphosphate to two triose compounds. So this is 3 carbon, this is also 3 carbon. Then the next is the interconvertible isomerization of, thus these two compounds are isomerized by the enzyme phosphotriose isomerase. So we have two isomerization so far, but the one that dominates is that the dihydroxy acetone phosphate is converted to glyceraldehyde 3-phosphate. Then the glyceraldehyde 3-phosphate is now oxidized here. A phosphate group is added. Okay, this is the end of the first step, because we have step 1, 2, 3, 4, and 5. This is step 1, step 2, step 3, then step 4. This isomerization is step 5. So this level now is just the first step, the energy consuming stage. We are now starting here with the energy yielding stage. So the first step here is that glyceraldehyde 3-phosphate is phosphorylated. Thus, an inorganic phosphate is added to it. Inorganic phosphate enters into it. Then there is a reduction also of NAD to NADH to form what we call 1,3-diorgis phosphoglycerate. So in this case, we find out the enzyme that is in charge of this level is glyceraldehyde 3-phosphate dehydrogenase. Glyceraldehyde Now, this is further converted to this level yields energy depending on if oxygen is present or absent. If oxygen is present or absent, then here we have the 1,3-diphosphoglycerate is now converted to 3-phosphoglycerate. 3-phosphoglycerate. The enzyme here is a kinase, and here there is a conversion, this time around, of ADP to ATP. That means energy is now generated. Anything that converts ADP to ATP is generating energy. And the enzyme involved here is phosphoglycerate kinase. That's the enzyme involved at this stage. Then there is a kind of isomerization again. This is the third isomerization of 3-phosphoglycerate to 2-phosphoglycerate. 2-phosphoglycerate. The enzyme involved in this reaction is phosphoglycerate mutase. Phosphoglycerate mutase. Then, it's a kind of isomerization. Here, there is a way to recover the phosphate group now added in the initial stage. Here we now have conversion of 2-phosphoglycerate to phosphoenol pyruvate. Phosphoenol pyruvate. The enzyme that does this is enolase. And this enolase, that's the enzyme that catalyzes this reaction, works well in the presence of magnesium ion or manganese ion also. Here, water is also liberated during this catalysis. Then phosphoenol pyruvate is finally converted to enol pyruvate. The enzyme involved here is a pyruvate kinase. Enol, please, that should be heard here. Pyruvate So at this level also, there is formation of ADP to ATP. ADP is converted to ATP, so it's energy yielding. Then, this spontaneously is converted to ketopyruvate or ketopyruvic acid. And that's what we call the pyruvate. And that's the end of glycolysis. So the process of changing this glucose to ketopyruvic acid is what we call, this is simple, glycolysis. But it cannot just go straight forward. These are the steps it must pass before coming here. So for glucose to be converted to ketopyruvic acid, it must first, watch it. The glucose is first converted to glucose 6-phosphate by the enzyme hexokinase. In the liver, it is glucokinase. That's the first step. And ATP is used up. So here we have -1 ATP is spent. That's why we say the first 5 stages energy consuming, preparatory. Then glucose 6-phosphate is further now converted to fructose 6-phosphate. Is isomerization, just changing the, you know that glucose is an aldose sugar, changing aldose sugar to ketose sugar by the enzyme phosphohexose isomerase. Then the fructose 6-phosphate is further phosphorylated again. That reminds me, at this stage, class, what we have is that there is also expenditure of ATP is hydrolyzed down to ADP, so energy is used up. So there is also presence of magnesium ion. And the enzyme in charge is phosphofructokinase 1, which means we have kinase 2. Don't skip watching these steps in detail. After this summary, I'll take the steps now in detail. So from fructose 6-phosphate to fructose 1,6-bisphosphate, the enzyme is in charge. This is the major enzyme that controls the rate of glycolysis. The key enzyme that controls glycolysis. Regulation matters here. Then this one, the fructose 1,6-bisphosphate now splits into 2 to give you dihydroxyacetone phosphate and glyceraldehyde 3-phosphate. These are 3, each of them is 3 carbon, while these are 6 carbons. Then the next step is the interconvertible, that's changing of dihydroxyacetone phosphate to glyceraldehyde 3-phosphate by the enzyme phosphotriose isomerase. Then we are done with the energy consuming stage. And here, remember, we have minus 1 molecule of ATP again. So at the energy consuming stage, you have spent 2 molecules of ATP. Then here is an oxidation of glyceraldehyde triphosphate to 1,3-diphosphoglycerate. This time around, converting an aldehyde to an acid, because this is also called 1,3-diphosphoglyceric acid. That is at this stage. It yields energy. Depending on this stage, it yields energy, but it depends on whether oxygen is present or absent. But it's marked where this is the stage where an inorganic phosphate is added. Pi means inorganic phosphate. Other phosphates here is from ATP. But the addition of phosphate here is an inorganic phosphate existing already in your body, is added into the glycolytic pathway, changing glyceraldehyde triphosphate to 1,3-diphosphoglycerate. The enzyme in charge is glyceraldehyde triphosphate dehydrogenase. Now, the next is conversion of this 1,3-diphosphoglycerate to 3-phosphoglycerate by just removing a phosphate group. So one of the phosphates here is now used to convert ADP to ATP. Here we now have yield, and energy is yielded here. 2 molecules of ATP here, because of the fact that we are talking about glyceraldehyde triphosphate and dihydroxyacetone phosphate. 2 of these is gotten from one of these, and each will pass through this. So which means when dihydroxyacetone phosphate comes here, it will still pass through the same process. That's why I have 2 here, but what we are seeing is 1. But due to the fact we have 2 molecules of triose sugar, this is showing a case of 1. So there are 2 molecules of ATP here yielded. Now, 3-phosphoglycerate is gotten from 1,3-diphosphoglycerate by the enzyme phosphoglycerate kinase. Then 3-phosphoglycerate is converted to 2-phosphoglycerate. This is a kind of isomerization, changing the phosphate group from carbon number 3 to carbon number 2. Then the enzyme is phosphoglycerate mutase. Is a kind of isomerase. This is another isomerization. At least we have 3 isomerizations in the glycolytic pathway, changing 3-glycerate phosphate to 2-phosphoglycerate. That's changing 3-phosphoglycerate to 2-phosphoglycerate is isomerization. Then changing glucose phosphate to fructose phosphate is the first isomerization. Then the second is the interconversion of glyceraldehyde triphosphate to dihydroxyacetone phosphate, or rather dihydroxyacetone phosphate to glyceraldehyde triphosphate. This is the second phosphorylation, while here is the third phosphorylation. So here is our first phosphorylation, here is our second phosphorylation, and here is our, not phosphorylation, please. Isomerization, please. We have 3 isomerization reactions in the glycolytic pathway. First isomerization is the change of glucose phosphate to fructose phosphate. Step 2 is isomerization. Then the second isomerization is the change of dihydroxyacetone phosphate to glyceraldehyde triphosphate. It's all about changing. The isomerization involved in the first step is converting ketone to alkanal, that's converting ketone to aldehyde. That's these 2, changing glucose to fructose, then changing acetone to aldehyde. It's the same thing, just changing the functional group this way, HCO to CO. This is for ketone, this is for aldehyde. But the third phosphorylation is changing of 3-phosphoglycerate to 2-phosphoglycerate. The functional group is not changed here, rather the number of carbon that bears the functional group is changed. So the isomerization here, isomerization here involves just not changing the functional group, unlike the first 2 changes the functional group. This one is changing the position of that phosphate group from number 3 to number 2. So the 3 isomerization reactions that are involved in glycolytic pathway are 1, conversion of glucose phosphate to fructose phosphate. Then number 2 is the conversion of dihydroxyl acetone phosphate to glyceraldehyde triphosphate. These 2 isomerization involves changing of functional group. That's it. Then the third isomerization is now occurring in the energy yielding stage, which is changing of 3-phosphoglycerate to 2-phosphoglycerate. This time around, unlike the first 2 isomerization, you are not changing the functional group here, rather you are shifting it from carbon number 1 to carbon number 2. So the 3 isomerization reactions has been explained that are involved in glycolysis. Okay, so this is the summary. We will now go into the details of each of the steps. But before then, you can make this like a little song to make it easier for you. You can say glue to glue 6p, glue to glue 6p, fruit 6p, fruit 1,6-dip, you see it? Glue to glue 6p, fruit 6p, fruit 1,6-dip, which splits into laceraldehyde 3-phosphate and dihydroxylacetone phosphate, which splits into laceraldehyde 3-phosphate and dihydroxylacetone phosphate. Now let's see the enzymes: hexokinase, phosphohexoisomerase, phosphofructokinase 1, and adolase, hexokinase, phosphohexoisomerase, phosphofructokinase 1, and adolase. Now let's see the energy yielding stage. You can answer which splits into dihydroxylacetone phosphate. The two triose compounds intercompatibly isomerize. That's the two triose compounds intercompatibly isomerize by phosphotriose isomerase. The two triose compounds intercompatibly isomerize by phosphotriose isomerase. Now let's see the energy yielding state. GL3P goes up to 1,3-bis phospho G. GL3P goes up to 1,3-bis phospho G. By GL3P dehydrogenase, then 1,3-bis phospho G is converted to 3-phosphoglycerate by a kinase, phosphoglycerate kinase, then to 2-phosphoglycerate by a mutase, phosphoglycerate mutase, then to phosphoenolpyruvate, then to phosphoenolpyruvate by enolase. By enolase, magnesium or manganese ion is there. Then phosphoenolpyruvate to enolpyruvate.
The glycolytic pathway song is here. Oh yeah. Oh, you there. Enjoy. The freestyle is here. Oh yeah. Oh, you there.
Don't forget to share this and ask your questions. Now let's go into the details of each step.